Hello everyone and welcome to Your Code Galaxy. Today we will talk about virtualization. In this video we will look at the core concepts of virtualization. Then we will learn about hypervisor. What are the benefits of virtualization? And in the end we will run our first virtual machine. So let's begin. What is virtualization? Virtualization basically means we are creating a digital copy of a computer system. Since it is a digital copy and not a physical computer, that is what makes it a virtual machine. This is possible because of three concepts, which are abstraction, resource pooling, and isolation. Let's understand these one by one. First one is abstraction. In a traditional computer system, we have one operating system that has direct access to the underlying hardware resources. This access is exclusive and the operating system has no intentions of sharing it. Abstraction cuts off this direct link between the OS and the hardware. Abstraction is made possible by something called the hypervisor. We will take a deep dive in what hypervisor is later in the video. Now, let's understand resource pooling. Once the abstraction layer has removed the direct link between the OS and hardware, we are able to pool the resources together. This means the hardware resources are now treated as shared instead of exclusive to just one operating system. And lastly, we have isolation. If the resources are to be shared, the entities that will be using these resources, that is, the VMs, need to be clearly separated for a clear and logical distribution of the resources. This means each VM is completely isolated from the other. Let's take a look at all these three principles in action as compared to a traditional computer system. The left image shows you how a traditional computer system with one OS has direct and exclusive access to the hardware resources. This means if any of the application crashes or misbehaves, it has the potential to take down the entire system with it. Additionally, the hardware resources are at a risk of underutilization, which means even if we have the hardware capacity available, it is sitting unused and idle. This is a very inefficient setup. In contrast, on the right, you will see multiple virtual computer systems running simultaneously and sharing a common pool of hardware resources. This ensures that our hardware capacity isn't wasted. Furthermore, isolation of each of those virtual systems ensures safety from a complete system shutdown due to a faulty application or some other reason. Even if one virtual system crashes, the rest of the system keeps on working. Before we jump into the world of virtual machines, let's take a quick look at the history of virtualization. In the 1960s, IBM introduced the first virtual machine concept with their CP40 and CP67 systems. Then, in late 90s, during the era of x86 systems, VMware used binary translations and made virtual machines a commercially viable option. In mid-2000s, Intel's VTX technology and AMD's AMD V technology enabled modern cloud performance. And now we have containerization, which has radically improved hardware efficiency. This is why you will find containerization at the heart of every modern architecture. Now let's take a look at the hidden star of the show, the hypervisor. A hypervisor, also known as a virtual machine monitor, is a software, firmware, or hardware that creates and runs virtual machines. It does the two main tasks. It acts as the abstraction layer, that is, it sits between the operating system and the hardware resources. Second, it performs the resource management for all the virtual machines. And because of these two things, the hypervisor is able to maintain a strict isolation boundary between all the VMs. Let's take a look at types of hypervisors. The first type of hypervisor is called Type 1 hypervisor, or the bare metal hypervisor. It has direct access to the hardware resources, because of which it is able to achieve near native performance. That means virtual systems running on this type of hypervisor are able to perform nearly as if they are directly accessing the hardware. Let's take a closer look. So, the Type 1 hypervisor sits directly next to the hardware resources. There is no host operating system between the hypervisor and the hardware resources. All the virtual machines access these resources through the hypervisor. And because the hypervisor is so close to the hardware, we get a very high performing virtual system. This type of virtualization is used by enterprise environment, like in the cloud services. This is because of the high operational efficiency of Type 1 hypervisor. Next, we have the Type 2 hypervisor, which is also called the hosted hypervisor. This type of hypervisor runs as an application inside the host operating system. Type 2 hypervisor doesn't perform as good as the Type 1 hypervisor, but it is very easy to install. The best example of this is the Oracle VirtualBox. It is mainly used for development, testing, or personal use. Let's take a closer look. The Type 2 hypervisor depends on the host operating system to interact with the physical hardware. The virtual system accesses the hardware resources through the hypervisor. It allows you to have multiple virtual environments in your personal computer. I would like to show you a high-level representation of how both Type 1 and Type 2 hypervisors interact with the hardware resources. For this, we will take a look at the CPU rings of privilege. CPU privilege rings is a concept by which every component of a computer system interacts with the hardware. The closer the ring is to the hardware, the better access it has to the resources. At the very center, we have the ring -1 or -1. This is where the root of Type 1 hypervisor lives. It is in direct contact with the hardware. Now we move further out to ring 0. This is where the OS kernel lives. If your system has Type 1 hypervisor, its engine lives here with the kernel. If you have a Type 2 hypervisor, in our case that is the Oracle VirtualBox, VirtualBox interacts with the hardware through the host OS kernel using the kernel drivers. The Type 2 hypervisor or the VirtualBox is divided into two parts. The first part, as we saw, is the kernel driver that lives in ring 0. The second part is the hypervisor application. It is the actual application that the user interacts with. This application lives in ring 3, like the rest of the applications in your system, like the Chrome browser. Despite all of this, there is a very clever technique by which modern hypervisors preserve performance. It is called the hardware-assisted virtualization. It uses the trap and emulate architecture to preserve performance while simultaneously keeping the system secure. Let's take a look. This is the trap and emulate architecture used in hardware-assisted virtualization. In this architecture, instructions that virtual machine execute are divided into two types: sensitive and non-sensitive. Sensitive instructions are the ones that have the potential to disrupt your host machine, like exposing a network port or changing your machine registry details. A non-sensitive instruction is simple, harmless code that doesn't affect the host system in any way, like copying data, renaming file, etc. The modern hypervisor is able to identify what type of instruction the VM wants to execute. If it is a non-sensitive instruction, it is directly sent to the physical hardware for faster processing. On the other hand, when the hypervisor detects a sensitive instruction, it is trapped and sent to the virtual hardware. Here, the virtual hardware executes this instruction and the result is sent back to the VM. This way, we are able to get native performance for harmless instructions while still maintaining security against potentially harmful code. Let's look at an example to understand this better. Here, we have two types of instructions that we talk about. On the left side, we can see how a non-sensitive code is directly executed on the physical CPU, giving us the highest performance. Since we are simply moving data between registers and doing simple addition, we know this code won't affect the current state of the host machine, so we can run this code on the physical CPU. On the right side, we have a sensitive code. We are reading from a network port and resetting the interrupt flag. This is risky code and can alter the state of the host machine. The CPU detects the sensitive code and passes it to the hypervisor. Hypervisor will execute this code on an emulated CPU and return the result back to the virtual machine, keeping the host machine secure in the process. It's cool, isn't it? Alright, now that we have thoroughly understood what hypervisor is and how it makes virtualization possible, let's look at virtual machines. The first principle that virtual machines work on is called encapsulation. A virtual machine is essentially a zip folder file that contains all the information and data about the virtual machine it represents. It has the operating system, disk size, memory allotted to the VM, all the config and all the applications bundled together in a single file. This single file can be copied, uploaded or shared to other machines just like any other file on your computer. Let's take a look. Let's say you created a virtual machine on your Dell computer. This VM is running Linux operating system and has a bunch of applications and data. All the information about the virtual machine is stored as a single file. Some of the common types of such files are .vdi or .vmdk. But commonly such file is called a machine image or simply image. Now you can copy this image on a thumb drive or upload it to cloud storage like Google Drive. You can then download this image on a separate computer. In our example, we copy our image to a HP computer. When we run this image as a virtual machine on this HP computer, it will run exactly as it ran on the Dell computer. This is how you can transport an entire computer virtually. This is possible because of the encapsulation feature of virtual machines. Now that we saw encapsulation, let's take a look at the next principle our VM works on, that is hardware independence. In the previous section, we saw how Hypervisor creates virtual hardware. Your virtual machine only sees this virtual hardware. This feature makes a virtual machine completely hardware agnostic. Let's take a look at how this works. Let's first see what does hardware abstraction looks like. In this image, the physical hardware on the left doesn't directly interact with the virtual machine on the right. Instead, the virtual machine gets its own virtual hardware that the hypervisor provides. So, how does this help the virtual machine be hardware agnostic? Let's take a look. Here, on the left, we have a virtual machine running on a Dell server with an Intel processor, DDR4 RAM, and Ethernet port. We moved our VM on an HPE server shown in the right that has an AMD processor, DDR5 RAM, and InfiniBand ports. Still, our VM runs exactly the same on both systems. This is because in both cases, our VM only interacts with the virtual hardware that is presented to it by the hypervisor. It is the hypervisor that translates all the different types of hardware into a common type of virtual hardware for the VM. This is what makes virtual machines hardware agnostic. The final feature of virtual machines is isolation. The virtual machine only interacts with the outside world through the hypervisor. This allows the hypervisor to set hard boundaries on each VM. Because of the strict boundaries set by the hypervisor, VMs cannot impact each other. This means if one VM gets infected by a malware or has a crash, the other VMs won't be affected and continue working normally. This makes virtualized systems very robust. Now that we have seen how virtualization and virtual machines work, let's understand what benefits we get from it. Virtualization gives you very high economic efficiency. As we saw in the previous sections, a single OS system hardware capacity isn't fully utilized. Before virtualization, only about 15% of the total hardware capacity was being used. Thanks to virtualization, that usage has gone up to 80%, significantly reducing idling and wastage. Earlier, a single server would only run one system. Now, because of virtual machines, one server can run up to 10 systems simultaneously. And since we are now able to group systems together on a single server, power and cooling costs went down by almost 50%. Let's take a look. Here, you can clearly see the benefits of virtualization. On the left, you'll find a conventional single system server. To run multiple systems, you needed multiple physical servers. Because of virtualization, we are able to reduce the physical hardware requirement and bundle multiple VMs on a single server. Another crucial benefit of virtualization is operational agility. Because of the encapsulation property and hardware agnostic nature of the VMs, we get two very important features that support continuous operation. First one being live migration of virtual machines without having to shut down the machine. This ensures zero downtime of your operations. And the second one is disaster recovery, which can be done by periodic and regular backups of your machine image and starting a VM from that backup when your primary machine goes down for some reason. This way, your operations experiences zero to minimum downtime. Let's see how this works. For live migration, you can copy the machine image of a running VM, transport it to a different location, and start your VM there. This way, all your application configurations and most of your data is ready and available while you can carry out hardware maintenance on the first system. This allows us to keep the operations going even during maintenance period. For quick disaster recovery, we can have periodic and regular backups of our machine image at an alternate location. This way, if for some reason our first system goes down, you can immediately start up a new VM from your latest machine image backup copy and have your operations up and running in minimal time. Virtualization is not just about server consolidation. It is the fundamental technology that makes cloud computing, microservices, and modern internet possible. While we have covered the immediate tangible benefits like higher server utilization and energy savings, the real story of virtualization is its role as a fundamental enabling technology. Virtualization is the core engine that allows cloud providers like Google, Amazon, and Microsoft to carve up massive pools of hardware and securely deliver those resources on demand to millions of customers. Without it, the cloud as we know could not exist. Microservices architecture relies on rapidly creating and destroying isolated environments. Virtualization and its evolution into containerization provides the essential isolation and portability needed for these small independent services to run reliably. The scale and resilience of today's internet, from massive e-commerce platforms to global video streaming, is only possible because of the operational agility and disaster recovery capabilities that virtualization provides. Now that we have seen why and the how behind the transformative technology, let's look at the practical side and show you how to set up your own virtual machine. To create our first virtual machine, we will follow these steps. You will need to enable virtualization in your system BIOS. This will depend on your manufacturer. I recommend checking a guide to enable virtualization on your specific machine. Next, we will download and install a Type 2 hypervisor on our machine. For our demo, we will be going with Oracle's VirtualBox, which is free to download. Next, we will define the resources for our virtual machine. Lastly, we will mount an operating system ISO file and install the operating system on our VM. So, go on and enable virtualization in your system BIOS and come back for next steps. Okay, now that you have enabled virtualization in your BIOS, we will now go ahead and download VirtualBox. For that, open a Chrome window. In the search box, type Oracle VirtualBox. In the search result, click on the downloads link. And on this page, we will click on Windows hosts. This will start a download. Since I have already downloaded the installer, I will cancel this. And once your downloading is finished, click on the click on the installer, and this will start the installation wizard. You will get a prompt that asks you, do you want to allow this app to make changes to your device? We are going to verify that the publisher name is Oracle America and then click yes. And this will begin the installation process. In the wizard, we will click next we will click on accept and then click next. Here we will keep the selection as it is and click next. When the installation happens, it will disconnect the network for a brief moment. I will click yes, then click yes, and finally next. At this window, we will click install. Now, let's let the installer finish installing. Once the installation is done, we will click finish. And now your VirtualBox is completely installed. To create your first virtual machine, we will need an operating system ISO file. Today, we will be creating a Linux-based virtual machine. For that, we will download Bodhi Linux ISO. To download that, let's go to our Chrome window. In the search tab, type Bodhi Linux, press enter, and then click on download. Here we will click on download for the first result, that is the standard release. Once you click on download, it should begin downloading automatically. Let's give it some time. I will cancel this download as I've already downloaded this ISO on my machine. But please let the downloading finish on your machine. Now, after the download is complete, I will go to my VirtualBox and click on New. Here, I will give my VirtualBox a name that will be Your Code Galaxy _ Bodhi _ Linux. And I will let the VM folder be as it is, or maybe I will change it to my desktop. I will come to my desktop, I will click new folder, and I will create a new folder called VMs. I will select this folder, and now it is asking me for an OS image. Here I will click on other, and on the desktop I have my ISO image copied. I will select that and click on open. Everything else I'm going to leave as it is and then click on next. Here we will specify the virtual hardware. Right now the memory is allotted as 2 GB. Number of CPUs as 1 CPU. Maybe increase it to 2. And disk size I will bring it down to 5 GB. And then I will leave everything else as it is and click on next. Once we have verified everything, we can click on finish. Now we will click on, I will right click here and I will click on start with GUI. Now this is going to power up my virtual machine. We also have to install the operating system. This might take some time. Now it is asking us what do we intend to do with the Bodhi Linux. Do we want to try it? Do we want to start it in a safe graphics mode? Do we want to install it? By default, it goes into installation mode, if we take too long to select, whenever you get a pop-up like this, just click on the X and we will let the Bodhi Linux get booted up. Once you come to this window, select English, click Next. I am going to select English US, click on Next. We will let it finish the installation. And there you have it. You have a virtual machine running Linux on your Windows machine. It is a fully functional Linux computer. And this is where we finish our virtual machine demo. Cut. Now that we were able to successfully run a virtual machine on our Windows machine, let's check out what was created in the folder where we saved our virtual machine. In here, you will see a folder was created with the same name as our VirtualBox. And in here, you will see a few files. One of them is the virtual disk image and another is the VirtualBox machine definition. I can pick up this file and send it to any other machine and run this file in the VirtualBox application in that machine, and my virtual machine will run exactly as it ran on my current machine. So this is the beauty of virtualization. And with this, we have completed our deep dive into the virtualization technology and also creating our first virtual machine on Windows 11. We hope this was a useful and informative video for all of you. For more videos, please subscribe to Your Code Galaxy. And don't forget to add your comments and tell us what did you think of this video. Thank you and have a good day.